Hello and welcome to this short instructional video on the basic functionality of the Galvo version of SciScan. My name is Bruno Pichler, I'm the lead author of SciScan. Please note that SciScan should always be started from the LabVIEW project explorer to ensure that the references are all correct. And then you run the Galvo version. It starts by loading up its modules, and you can see after a few seconds the focus button and the record button become enabled, and then everything's ready to go. Over here you see the main imaging area. Down here is the settings area, and up on the right you can see the area for controlling the stage. Down here we've got a little notebook where you can make notes during the recording. You can also open all the advanced settings or close them here depending on your particular needs. You can also close the different tabs individually just by unpinning them here. Now, the first thing I want to talk about here is the settings for your 2D frame scanning. You can specify the number of frames that you want to record. You can choose a scan speed, which determines the pixel dwell time. You can then choose your pixel resolution here from a drop-down menu. I'll leave that at 256 by 256. You can then set a zoom factor. And it will then display the field of view in microns down here. On the General Settings tab, you can choose your root folder. So for this demo here, I'm just use that current folder here. You can then specify an experiment name. That will become part of your file name when the images are recorded. You can choose from various different file formats here in the Galvo version. I'm going to leave that at TIFF. And then here in the center we've got our main controls. There's a cancel button, a record button, and our focus button. When I press the focus button, you can see that after a few seconds an image will appear, in this case an image of pollen grains. Channel 2 isn't connected to anything, so it's just white, and channel 3 and 4 are inactive here. So when you look at the old channels tab, channel 2 has a white image, 3 and 4 are inactive. The RGB tab here allows you to overlay channels in different colors for colocalization studies. As we're only recording one channel here, it's not very impressive, but you get the idea of what this can do when you have more than one channel. On the ROI tab, you can draw regions of interest around structures that you're interested in and plot the average grayscale value over time, as you can see here in the chart below. I'm now going to use the scientific control cube to move my stage in X and Y, just to demonstrate how the average value changes and how you're plotting that in the waveform chart. You can also change which channel you're doing this on, but again we only have channel 1 here. Sometimes when you're scanning in bidirectional mode, you might notice these double images, especially when you go to faster dwell times or change some parameters. And these are caused by what we call the start delay. So if the forward and backward line are not perfectly aligned, you might need to correct for that. And this green button that you see here, it tries to auto-calibrate that. I'm getting this warning message here that tells me that I need to switch on the averaging. So I go here and just set the averaging type to moving average. And then if I hit the green button again, it auto-calibrates and determines the best start delay here. So typically when you change the scan speed or the zoom factor, or as I do here the dwell time, then you might find that you get these double images, and that just means the start delay is not optimally set, so you just auto-calibrate it and it will then come back and give you the correct image. So now that I've set my start delay correctly, I now want to double check that I have all my file name and folder set correctly here in the general settings before I do a recording. And when I'm happy with that, just specify the number of frames that I want to acquire. And then when I hit record, you can see that I'm getting an entry down here in my notebook. I can then start typing notes in there, and that will be saved along with my TIFF file. So let's just navigate to that folder. The folder that we use has a date stamp, And then inside that folder we have another folder with the date stamp and the timestamp and the experiment name. And inside this folder we have all our metadata, we have our experiment notes, and we have the TIFF files that we can then open in ImageJ, for example, and analyze here, or we can also load them in any other analysis workflow in MATLAB or Python or any other software. The next thing I want to demonstrate here is how to record a Z-stack. So for that I'm just going to choose a starting plane for my Z-stack, just above our plane of pollen grains here. Then I'm just going to adjust the laser power a little bit as well to get the correct excitation power for my sample in this very plane. And then once I'm happy with all those settings, I can navigate to my Z-stack tab here and I add my first reference plane to my list here on the right. And I can move the stage and move it to some intermediary plane. And then again adjust the laser power. It's a little bit much here, so I'm turning it down a little bit, and then I add another reference plane. And I just add 2 or 3 planes here. On the Z-stack tab you can also choose the Z spacing between the planes and how many frames per plane you want to record. But here for that example I'll leave them as they are, and I just move to the Z-stack start plane. Then I hit start Z-stack, and you will see how the stage is now automatically stepping through that volume that I've defined on that table on the lower right hand side. I'm just going to run that again here quickly just to demonstrate how the laser power is moving as well at the same time. Depending on the Z spacing that's configured here, both the laser power and the XYZ positions will be interpolated from the table on the lower right hand corner and will then automatically be executed. If your multiphoton system has a piezoelectric objective driver installed as well, you can configure that on the piezo tab here. There are different piezo modes and different speeds that you can configure, but all that configuration will use the same values as in the table that you configured for the Z-stack. So the configuration of those values will be exactly the same. The next thing I want to briefly demonstrate is how to configure an arbitrary line scan. So for this we just navigate to the arbitrary line scan tab, choose a channel, and we can see our pollen grains here. You can choose either a polygon tool or a freehand tool to draw your line. So just by clicking at the positions you can see how you can feed your line through the different areas of interest here, and then just double clicking closes that line. When you're happy with that, you can then confirm that line. You will see it adds a little red flag there that indicates the origin and the direction in which the mirror is going to move. And then you can hit focus just to double check that it has the correct 5 structures, in this case here, line by line. And then we can just record that. Then you can see on the right hand side in that line scan tab the different parameters, so you can specify the total number of lines to acquire and the lines to be displayed at once. And when you navigate to your saved folder here, there's a TIFF image of that line scan image and also a list of coordinates corresponding to each of the pixels in your line. When you then look inside the folder, again there's a TIFF image. You can open that in ImageJ and use that for further analysis. This concludes this little instructional video here. Obviously there's a lot more functionality to SciScan, both in the Galvo version and in the resonant version, and you can find a lot more info about that online in our online guide at sciscan.scientifica.uk.com. Or you can contact your Scientifica representative, who of course will always be happy to help you with any queries regarding SciScan or any other of our products. Thank you very much for your attention.